Very, very important. First law of thermodynamics. There are mainly three laws. One is first law of thermodynamics. Second is second law of thermodynamics. And third law of thermodynamics. But in our syllabus, we're going to study mainly first law of thermodynamics and second law of thermodynamics. Students, all thermodynamic laws are completely human experience. Human experience. And coming to first law of thermodynamics, energy can neither be created nor be destroyed, but one form of energy converted into another form. That is first law of thermodynamics. It is completely human experience, and no doubt you cannot say this statement is wrong. Yes, this statement is correct based on number of experiments. And it is also called law of conservation of energy. Law of conservation of energy is the first law of thermodynamics. Okay, students, write down. Energy can neither be created nor be destroyed, but one form of energy is converted into another form. And another statement regarding first law of thermodynamics, students. It is impossible to construct a perpetual mission which which can do work, which can do work by which can do work without consuming energy. So second statement you can write, we cannot construct a perpetual mission. What is perpetual mission? Uninterrupted mission. Uninterrupted mission which can do work without consuming energy. So students, according to first law of thermodynamics, energy can be converted into one form to another form. So if you take energy, by using that energy we can do work. So without consuming energy, you cannot produce any work by any machine. That is second statement regarding first law of thermodynamics. Understood? Students, in waiting room, almost 3 members are there. I won't allow them for today's class because they came after 4 minutes. I said before 3 minutes you have to enter into class. Tomorrow onwards, Before 3 minutes, you have to enter into the class. After 3 minutes, I won't allow you. Already waiting room, already 3 members are there. Yes, thank you very much, students. Almost all students, they entered within 1 minute. Thank you all. Students completed. Okay. And what is the mathematical representation of first law of thermodynamics? Let us consider a system, a substance. Okay. This substance internal energy is U. Let's say it is U initial, or you can say U1. If I supply Q amount of heat to this system, so I provided some amount of energy to the system, that is heat energy. And also I did some work on this system. So I passed some amount of heat energy. I did some work on the system. Then system converted into another state. Then definitely the internal energy will change. So that is U2. According to first law of thermodynamics, whatever energy is given to this system, it must be equal to total energies. So we can write U2 equal to U1 plus W plus Q. So here plus WY work done on system plus QY energy, heat energy provided to system. So plus and minus are very important. Then U2 minus U1 equal to Q plus W. U final state minus U initial state is change in internal energy equal to Q plus W. Students, it is called first law of thermodynamics mathematical expression. Change in internal energy equal to Q plus W, and Q equal to delta U minus W. So what is W? W equal to minus P external into dV. So delta U equal to Q minus P dV. Understood? Students, I'm repeating again. See, there is a one system at internal energy U1. Okay. If I do some work on this system W, and if I pass some heat energy to the system, it converted into another state. In another state, definitely the internal energy would change. So that is U2. According to first law of thermodynamics, whatever energy is given to this system, that is completely, we cannot create, we cannot destroy. So U2 equal to U1 plus W plus Q. From this, U2 minus U1 equal to Q plus W. Internal energy change here. So delta U equal to Q plus W. And this is called equation for first law of thermodynamics. Yes, completed. Next, we need to get some information from first law of thermodynamics, the information regarding thermodynamic process. So what is the first law of thermodynamics in isothermal, adiabatic, isochoric, isobaric? And so in isothermal process, students, we know that temperature of the system is constant. So change in temperature is zero. First law of thermodynamics is delta U plus Q plus W. So one important point here, internal energy is a function of temperature and volume. So a system at A state, if it is converted into B state, A state and B state, internal energy, if temperature of the system at A state T, even B state also T, same temperature. Students, in case if you do not change temperature, internal energy also do not change. So change in internal energy at constant temperature, zero. Delta U equal to zero in isothermal process, since U is a function of temperature, and we already studied average kinetic energy directly proportional to absolute temperature. So all forms of energies, kinetic energies, rotational energy, vibrational energy, potential energies, all are related to temperature. If you change temperature and mass, definitely there will be change in internal energy. Here system mass is same, but in case if temperature also same, internal energy would be zero. So equation is 0 equal to Q plus W. So Q equal to minus W, or minus Q equal to plus W. And what we can understand from Q equal to minus W minus Q equal to plus W. From this equation, we can say plus Q. Plus Q means heat absorbed by system. When a system absorbed heat, the system can do work by itself. Okay, so students here, in isothermal process, system, if system absorbed heat, it can do work by itself. So whatever energy, heat energy passed to the system utilizes that work, that heat energy to do some work. And another case, minus Q, heat released by system, plus W, work done on system. Suppose in case if you do work on system, the system can release heat to the outside. So students, if work done on system can utilizes can system can release heat to the surroundings, to the just releases heat, simple. So students, here you need to understand these 2 points. In isothermal process, temperature is constant, so change in temperature is zero, so that internal energy is zero. అంటే ఐసోథర్మల్ ప్రాసెస్ లో మీరు ఇచ్చిన హీట్ సిస్టమ్ ఏం చేస్తుందంటే సిస్టమ్ తనంతట తాను వర్క్ చేయగలుగుతుంది మీరు ఇచ్చిన హీట్ వల్ల. ఒకవేళ ఇన్ అదర్ కేస్ మనం అర్థం చేసుకోవాల్సింది ఏంటంటే, సిస్టమ్ ఒకవేళ మనం వర్క్ చేయగలిగితే, సిస్టమ్ పైన వర్క్ చేయగలిగితే, సిస్టమ్ జరిగిన వర్క్ వల్ల సిస్టమ్ కెన్ రిలీజ్ హీట్ టు ద అవుట్ సైడ్. సో అలాంటి వర్క్ మనకి, అంటే అలాంటి ప్రాసెస్ జరుగుతుంది ఐసోథర్మల్ లో మనకి. అంటే ఇంటర్నల్ ఎనర్జీలో ఎటువంటి చేంజ్ ఉండదు, అక్కడ హీట్ వర్క్ మధ్య మనకి ఎనర్జీ కన్వర్షన్ జరుగుతుంది. స్టూడెంట్స్, డూ యూ అండర్స్టాండ్? ఎస్, కంప్లీటెడ్. రైట్. నెక్స్ట్, in adiabatic process, what is adiabatic process? System cannot release heat, cannot absorb heat, so q equal to 0, dq also 0. And first law of thermodynamics, delta u equal to q plus w. Q equal to 0, then delta u equal to w. In another way, we can write minus delta u equal to minus w, plus delta u plus w. So what we can understand from adiabatic process, system cannot take heat energy from outside. It cannot release heat energy to the outside. Okay. Then how system can do work? Plus W. So students, if system if work done on system utilizes that to increase its internal energy. Students, very very important. ఇక్కడ మీరు సిస్టమ్ కి ఎటువంటి హీట్ పాస్ చేయట్లేదు, సిస్టమ్ కూడా హీట్ ని బయటకు ఇవ్వట్లేదు. అప్పుడు ఏం చేస్తుందంటే, ఇన్ కేసు మీరు సిస్టమ్ పైన వర్క్ చేయగలిగితే, సిస్టమ్ ఏం చేస్తుందంటే ఆ వర్క్ జరిగింది కాబట్టి దాన్ని, ఆ ఎనర్జీని ఇంటర్నల్ ఎనర్జీగా కన్వర్ట్ చేయగలుగుతుంది. సో దట్స్ వై ఇఫ్ వర్క్ డన్ ఆన్ సిస్టమ్, the system utilizes that to increase its internal energy. In another case, minus delta u minus w. ఒకవేళ సిస్టమ్ తనంతట తానే వర్క్ చేయగలిగితే ఎలా చేయగలుగుతుందంటే, బై యూజింగ్ ఇట్స్ ఇంటర్నల్ ఎనర్జీ. సో సిస్టమ్ యూటిలైజెస్ ఇట్స్ ఇంటర్నల్ ఎనర్జీ టు డూ వర్క్ బై ఇట్ సెల్ఫ్. సిస్టమ్ కెన్ డూ వర్క్ by itself to do to itself by itself by using its internal energy. సో అందుకే మనకి ఇంటర్నల్ ఎనర్జీలో చేంజెస్ రావడం వల్లే టెంపరేచర్లో చేంజెస్ వస్తాయి. సో adiabatic process, heat is zero, but temperature difference is present in system because system utilizes its internal energy to do work. స్టూడెంట్స్ అర్థం, ఈ కాన్సెప్ట్ చాలా ఇంపార్టెంట్ స్టూడెంట్స్, మీకు అర్థం కావాలి ఈ కంప్లీట్ డేటా. In case if you have any doubt, you can ask any question, students. Yes, the sound energy nothing but vibrational energy. I said sound energy related to vibrational energy. Vibrational energy related to internal energy. Because of vibration of molecules, we'll get sound. Students completed. Okay. Next, isochoric process. What is isochoric process? Volume of the system is constant. So dV equal to 0. First law of thermodynamic equation, delta U equal to Q plus W. What is W? W equal to minus PdV. So dV is 0. So equation delta U equal to plus Q, or you can write minus delta U equal to minus Q. So what we can understand from isochoric process? Isochoric process work done is 0 because there is no change in volume. So one important point, in isochoric process work done equal to 0. So work జరగనప్పుడు ఏమవుతుంది? So in case there is no work, then whatever heat energy supplied to the system utilizes that energy to increase its internal energy. Or if system releases some amount of heat, that heat can by using its internal energy. Understood? So students here, if heat supplied to the system it utilizes to increase its internal energy. In another way, what we can understand, system can release heat by using its internal energy. అంటే ఇంటర్నల్ ఎనర్జీని హీట్ గా కన్వర్ట్ చేయగలుగుతుంది ఎప్పుడు ఐసోకోరిక్ ప్రాసెస్, బికాస్ దేర్ ఇస్ నో వర్క్ డన్. Yes, Rohit, yes, zeroth law also there. Generally, third law of thermodynamics and zero law of thermodynamics both are same. Actually, third law of thermodynamics, they have given after giving first law of thermodynamics and second law of thermodynamics. But it is most fundamental concept, that is zero of thermodynamics. I will explain that. Okay. Students completed? Right. Everybody? Next, in adiabatic process over. Next, isobaric process. In isobaric process, students, P is constant, pressure of the system is constant. So dP equal to 0. dP equal to 0. What is the first law of thermodynamics? Delta U equal to Q plus W. What is W? U2 minus U1 plus minus P delta V. What is delta V? Delta V is V2 minus V1, V final minus V initial. U2 minus U1, Q minus PV2 minus plus PV1. And you can write this equation Q equal to U2 plus PV2 minus U1 minus PV1. U2 plus PV2 minus of U1 plus PV1. Students, actually at constant pressure, you cannot say what is the scenario, because no term is cancelling here, because we are doing P delta V. So there is no change in pressure. dP, if dP is there, we can cancel. So P delta V. They introduced one more energy form, because there are different types of energy: sound energy, vibration energy, rotational energy. Yes, all energy is same. To for understanding purpose, in how energy converted into one form to another form. So they introduced a new term. The term is enthalpy. Enthalpy H, that equation they have taken from this formula U2 plus PV2 U1 plus P1. So internal enthalpy formula U plus PV. So Q equal to H2 minus H1, that is equal to delta H. So students, at constant temperature, at constant pressure, if you do some work or if you do something, the heat energy should not called as a heat, you should call it as a enthalpy. So enthalpy is a heat content of system. So write down first, just here, if you do a process, isobaric process, the amount of heat energy released or absorbed, you should not call it as a heat, you should call it as a enthalpy. So it is another form of energy. So we need to so one example, students, why we need different forms of energy, because to understand, for it is an understanding purpose. Example, a person, Rahul, let's say Rahul, he can play volleyball, he can play cricket, he can play chess, but he's a student. Okay. When he enter into cricket ground, he can play cricket. So at that time, you can call that Rahul as a cricketer. Same person, if he play volleyball, yes, he can play volleyball sport. If he can play chess, yes, at that time you cannot talk about cricket. So when he's in a classroom, he's a student. Same, the person is same, but in different situations, we are calling him as a different names. Are you getting my point? Similarly, we are doing a some process to identify the change in energy. We are calling as a enthalpy, internal energy, different forms of energy. So if you do process like isobaric, in that the heat energy is should be, we can call as a enthalpy. So enthalpy, another formula, H equal to U plus PV. Students, are you getting my point? Yes, it is for our convenient. It is for our convenient to understand things very easily. So please note on this. Completed, Nana? Okay. So a new term is introduced, that is enthalpy. Let's study about enthalpy. Enthalpy. Heat content of system measured at constant temperature and pressure is called enthalpy. So students, enthalpy is a function of temperature and pressure, whereas internal energy is a function of temperature and volume. అంటే సేమ్ ఎంథాల్పీ, ఇంటర్నల్ ఎనర్జీ రెండు ఎనర్జీసే, బట్ ఇక్కడ ప్రెషర్ ఈస్ కాన్స్టెంట్, ఇక్కడ వాల్యూమ్ ఈస్ కాన్స్టెంట్. సో ఆ డిఫరెన్స్ మనం తెలియడానికి డిఫరెంట్ ఫార్మ్స్. సో హెచ్ ఈక్వల్ టు యూ ప్లస్ పివి, దిస్ ఇస్ ద ఈక్వేషన్ రిలేషన్ బిట్వీన్ enthalpy and internal energy. So delta H equal to delta U plus P delta V. Students completed. Now, properties of enthalpy. Enthalpy, it is a extensive property. It is an extensive property. Yes, definitely enthalpy depends upon mass of the system. Extensive property. And it is a state function. Like internal energy, we cannot find exact value of enthalpy. We can find change in enthalpy. So delta H equal to H2 minus H1, final minus initial. Example, all chemical reactions, 99% we do at constant pressure and at constant temperature. Almost all chemical reactions. So reactants converted into products, then delta H equal to enthalpy of products minus enthalpy of reactants. If delta H in case positive value, delta H positive, then products minus reactants, this is positive. This is called endothermic reaction. We already studied endothermic reaction. Reactants energy is very low so that we supply energy. That's why endothermic reaction. So endothermic reaction, enthalpy of products are greater than enthalpy of reactants. In case delta H is negative, it is exothermic reaction. Students, if you see the representation of exothermic reaction and endothermic reaction, normally we can represent delta H. Have you seen in lower classes? We represent with delta H because delta H is a representation of energy at constant temperature and pressure. Now here heat of reactants are greater than enthalpy of products. Students, are you getting my point or not? Students completed? Okay. A system is provided 50 joules of heat and work done by system is 20 joules. Find change in internal energy. Shashank, very good. Likith Naidu, okay. Srivardhan, okay. Vikrant, very good. Ramya, okay. Ropak, okay. Sidhu, okay. Okay, right. Change in internal energy delta U equal to Q plus W. This is the equation. A system is provided 50 joules of heat. Provided means we supplied. So it is a positive value plus 50. Work done by system. So notation is minus W. So minus 20. W is minus. So minus 20. Answer. Got it? Students, understood or not? అందుకే నేను టర్మినాలజీ చాలా చాలా ఇంపార్టెంట్ చెప్పు. వర్క్ డన్ బై సిస్టమ్ W వాల్యూ minus W. So if W is 20, that is minus 20. Understood or not? అదే మీరు వర్క్ డన్ ఆన్ సిస్టమ్ అంటే 70 వాల్యూ వస్తుంది. ఓకే, నెక్స్ట్ క్వశ్చన్. When 2 moles of iron reacts with 5 moles of HCl in a closed vessel, calculate work done in this process. Yuvatej, okay. Shashank, very good, Shashank. Shashank, can you explain? Shashank, can you explain? Okay. So question is, when iron react with HCl, we'll get FeCl2 plus H2. So it depends upon number of moles of hydrogen released in the equation, because work done equal to minus PdV. So PdV we can write minus nRT. Number of moles of hydrogen released at temperature, we can find minus nRT value. But it is a closed vessel. In closed vessel, change in volume is 0. So work done is 0. Understood? So in a closed vessel, if you do a chemical reaction, work done equal to zero, because there is no change in volume. Got it? Okay, students, in